and put them between 3 and 81. So 3, G1, G2, 81. Total 4 terms are there. The best method is take LHS, simplify, get an intermediate result. Then take RHS and simplify, get another result. I'm using law of indices. A per m whole per n is A per m into n. So if the terms are in GP, for each term you multiply R. So here they give geometric mean is this. What is geometric mean? A per n plus 1 plus B per n plus 1 by A per n. AB plus BC plus CD. When you substitute, again you will get A power 4 R square. Welcome to the session, dear students. Today we'll go ahead with the problems of sequence and series, that is exercise 9.3, problem number 25. So they gave if A, B, C and D are in GP, show that A square plus B square plus C square into B square plus C square plus D square is equal to AB plus BC plus CD whole square. See here, there are two methods to solve this. The best method is take LHS, simplify, get an intermediate result. Then take RHS and simplify, get another result. Both LHS and RHS should become same. So before that, A, B, C, D are in GP. So let us assume. So let A is equal to A, B is equal to AR, C is equal to AR square, D is equal to AR cube. Because they are in GP, or of each term in GP will have common ratio. So A, AR, AR square, AR cube are the 4 terms in GP. But they gave A, B, C, D. So I'll assume A is A and B is equal to what? AR, C is equal to AR square, D is equal to AR cube, because they are in GP. The terms in GP will be what? A, AR square. For every term you multiply R, you will get next term. So if A, B, C, D are in GP, then A is A, but B is AR, C is AR square, D is AR cube. This is first assumption. Be the numbers in GP. Be the numbers. And why? Because they are in GP, so each term gets multiplied with R. Now we'll take LHS. So what is LHS? A square plus B square plus C square into B square plus C square plus D square. Now substitute A, B, C value. A is A, so it is A square. B is what? AR the whole square. C is AR square. C square means AR square the whole square into B square. B, what is B? AR. I'm substituting. B square means AR square. C square means AR square the whole square. D square. D square means AR cube the whole square. So now simplify this. So you get A square plus A square R square. A square R square plus A square R square whole square becomes R power 4 into, take it inside, so it will become A square R square plus A square R power 4 plus A square R power 3 to the 6. So now in each term you can take A square common. If you do that, it will be A square. If I take common, I will be left out with 1 plus R square. See here, first I will write the same term, A square R square. A square plus A square R square plus what we have, A square R power 4 into A square R square plus A square R square plus A square R power 4 plus A square R power 6. Now further in these two, in each term I can take A square common. If I take A square common, 1 plus R square plus R power 4. Again here if you take, and also you can, okay, here if I take A square common, I can take common as A square and R square. A square R square, if I take common, it will become 1. A square is already out, R square is out, it will become R square plus again A square and R square is taken out, so it will become R power 4. Again if you observe, A square into A square, I can write it as A power 4 R square, and 1 plus R square plus R power 4, 1 plus R square plus R power 4. see 1 plus into 1 plus r square plus r power 4. So these two are similar. So whole square I can write. So now you got LHS value. What is LHS? You got a power 4 r square 1 plus r square plus r power 4 the whole square. Call it as equation 1. So dear students, we took LHS. LHS is a square plus b square plus c square into b square plus c square plus d square, and the value of that we got a power 4 r square into 1 plus r square plus r power 4 whole square, because this a plus b into a plus b is what? A plus b the whole square. Similarly, 1 plus r square plus r power 4 into 1 plus r square plus r power 4, I can compress this as whole square. Now we'll take RHS. So we'll take RHS. In RHS we have AB, BC, CD whole square. So AB plus BC plus CD the whole square. Substitute the values. A is A, B is what? AR, and B is AR, C is AR square, and C is AR square into D is AR cube whole square. I am substituting the value of A, B, C, D. So you know A is A, B is AR, C is AR square, D is AR cube. That's what I have substituted here. Now further we'll simplify this. A into A is A square R plus A into A is A square R cube plus A into A is A square R power 5 whole square. Further we can take A square common and also R common. If I take A square, so what is left out? A square R plus A square R cube plus A square R power 5. A square R power 5 whole square we have. So here in the internal terms I can take A R common. AR I'll take it out. So or A square R, if I take common, this will become 1 plus this will become A is R, A square is already out R, and this will become R power 4 and whole square. So now take square for both the terms. So it will become A square whole square R square 1 plus R power 4 the whole square. So it will become A power 4 into R square into 1 plus R power 4 the whole square. So this is RHS. Call it as equation 1, 2. So now 1 we got A power 4 R square into 1 plus R square plus R power 4 whole square. 2 also we got A power 4 R square into 1 plus R power 4. So therefore from 1 and 2, from equation 1 and 2, both LHS value is same as RHS value. That is what? AR power 4 R square 1 plus R power 4 the whole square. You can see both we got same. So we got this equation 1 and we got this equation 2. From 1 and 2, what is the conclusion? LHS is equal to RHS. Therefore the conclusion is simple. We can equate both. So therefore A square, therefore what is the conclusion? A square plus B square plus C square into B square plus C square plus D square value is same as AC BC CD, AC plus BC plus CD the whole square. Hence the proof. I hope all of you understood this. One of the important problem. So but here the problem stands with assumption. See dear students, so first we have to assume what are the numbers? A, AR square, AR cube. So these are the numbers in GP. You know, if the numbers are in GP, they should have common ratio. First is A, second A into R, third A into R into R, then like that. So ABCD they gave. So we assumed ABCD as what? AR square, AR cube. Then we took LHS. What is LHS? LHS is what? A square plus B square plus C square into A B square plus C square plus D square. I took that. I substituted. A is A. B instead of B put what? AR the whole square. B square means whole square. C square means C value is AR square the whole square into. So B square plus C square plus D square. Substitute it. Simplify and take common. Taking common. So here I took A square common. Then here I took A square R, this term common. So you can see these two terms are same, this and this. So you can multiply, when multiply it will become whole square. So from 1 and 2, LHS and RHS are same. So a second equation also. Second equation is what? AB plus BC plus CD. When you substitute, again you will get A power 4 R square 1 plus R power 4 whole square. So from 1 and 2, LHS and RHS are same. Hence the proof. One of the good problems. Next, insert two numbers between 3 and 81 so that the resulting sequence is in GP. So let us assume, let G1 comma G2 be the two numbers, that we are going to insert between the numbers. Then the sequence will be what? 3, G1, G2 and 81. So we have 4 terms. This is the first term, this is the second term, this is the third term, this is the fourth term. So therefore A4 is what? 81. You know A4 in GP, you know, in GP, nth term is what? AR power n minus 1. So A4 is A4 power AR power 4 minus 1 is 81. So simplify this. AR power 4 minus 1 is 81. A means the first term. What is the first term? 3. So 3 into R cube is equal to 81. So what is R cube? R cube is what? 81 by 3. So R cube is what? 81 by 3 means 3 27s, 3 1s, 3 27s. So I can write R cube is equal to 3 cube. So therefore by method of comparison, R is what? 3. Got common ratio. So if the terms are in GP, for each term you multiply R. So we took 3, G1, G2 and 81 are the numbers. So multiply R. 3 into what? 3 into 3 square, then 3 into 3 cube. So AR square, AR cube, they are in GP. So 3 3s are 9, 9 3s are 27, 81. So therefore what are the numbers? Therefore 9 and 21 are the 27 are the numbers. Once you include them, they are in GP. So now 3, 9, 27. So simple, dear students, if they ask you to introduce two numbers between the numbers so that they'll become GP, means assume the numbers as G1 and G2. I'm taking the numbers as what? G1 and G2 and put them between 3 and 81. So 3, G1, G2, 81. Total 4 terms are there. So fourth term is 81. So you know nth term in GP. What is nth term in GP? An is AR power n minus 1. So fourth term is A into R power 4 minus 1 is 81. So AR cube is equal to 81. Solve it, you will get R value. R value is what? 3. And for each term you multiply R, you will get next term. 3 3s are 9, 9 3s are 27, 27 3s are 81. So these are the numbers, and 9 and 27 are the two numbers which you are supposed to introduce between 3 and 81. Next we have, find the value of n so that a power n plus 1 plus b power n plus 1 by a power n plus b power n may be the geometric mean between a and b. So geometric mean between a and b is that. So therefore let us assume whatever is given. So let us write what is given. Given geometric mean of two numbers is a power n plus 1 plus b power n plus 1 by a power n plus b power n. Now you know what is geometric mean. Geometric mean means we know the value of geometric mean. So this is one given thing. But you know geometric mean means what? Root AB. This is geometric mean actually. So now geometric mean is root AB, that they have given like this. So now we need to simplify and solve to get the answer. So here a power n plus 1 plus b power n plus 1 by a power n b power n is equal to root AB. Geometric mean means what? Product of two numbers under root. Now squaring on both sides. If I squaring on both sides, a power n plus 1 by b power n plus 1 by whole square, by denominator also a power n plus b power n whole square is equal to root ab the whole square. Now numerator a plus b the whole square, a square plus b square plus 2ab, a plus n plus 1 the whole square plus b power n plus 1 the whole square plus 2 times a power n plus 1 into b power n plus 1 is equal to root ab the whole square is what? AB. denominator a plus b the whole square, a power 2n plus b power n the whole square, b power n the whole square, a power n the whole square plus 2 times a power n b power n. Further we'll simplify this. If you use law of indices, we will get a power 2n plus 2 plus b power 2n plus 2 plus 2 times a power n plus 1 b power n plus 1 is equal to cross multiply. We'll get ab into denominator, it will be a power 2n plus b power 2n plus 2 times a power n b power n. Now further simplify, it will become a power 2n plus 2 plus b power 2n plus 2. I'm using law of indices. A power m whole power n is a power m into n. N whole square is n into 2 2n. So here also whole square will be there. A plus b the whole square is what? A square plus b square plus 2ab. And whole square when you do n into 2 2n, again n into 2 2n. So here 2 power 2 into a power n plus 1 into b power n plus 1. If you multiply this, if I take term a into a power 2n plus 1, it will become law of indices. All of you know a power m into a power n is what? A power m plus n. So a into a power 2n is a power 2n plus 1 into b. This b comes as it is, b power 2n plus 1 because b into a plus 2 times a power n plus 2 into b power n plus 2, n plus 1. If you multiply this 2, b power n plus 1 into n plus 1, sorry, n plus 1. See both the sets, here also I have 2 into a power n plus 1 b power n plus 1. Here also I have 2 into a power n plus 1 b power n plus 1. And both the sets we have same terms of, see this is equal to, on both the sets we have same terms, I can cancel this directly. Now further simplification, further simplify. So group all the terms, I will bring this a power thing to LHS. So I have a power 2n plus 2 minus a power 2n plus 1 into b. I'll transfer this to RHS, so it will become a into, or b power what we have, 2 power n plus 1 into a minus b power 2n plus 2. So in these two terms we can take common. I'll take, say dear students, here 2n plus 2 means 2n plus 1 into 2n plus 2. So a power 2n plus 1 you take common. So this will become a minus b. Similarly here you take b power 2n plus 1 common. So it will become a, and this whole thing is common. So b power 2n plus 1 you take common. Sorry, this is b power 2n plus multiply a. So a into b power 2n plus 1. From this b power n plus 2 if you take common, n plus 1 if you take common, it will be into b, sorry. One term b left out. See now use law of indices. So dear students, b power 2n plus 2 can be written as b power 2n plus 1 plus 1. So that this part again I can write b power 2n plus 1 into b. And this we took common. So now a minus b cancels. We are left out with, so we are left out with a power 2n plus 1 is equal to b power 2n plus 1. So now bring, see I can, powers are same, I can't equate the bases, but reason is I am interested to get what is called as n value. So bring it to LHS. If I bring it to LHS, a power 2n plus 1 divided by b power 2n plus 1 becomes 1. Further, a by b whole power 2n plus 1 becomes 1. So bases, see powers are same. Powers are same. So a power 2n plus 1 by b power 2n plus 1, a by b whole power 2n plus 1 I can write is equal to 1. So you know, if RHS has to be 1 means the power has to be 0. So therefore anything power 0 gives you 1. So from this equation, I call this as equation 1. So let me justify here. From 1 I can say 2, the power is to be what? 1 0. So because RHS is what? 1. You know, anything power 0. So therefore what is the conclusion? A by b power 0 can become 1. So therefore this 2 power n plus 1 has to be what? 0. So from this 2n is equal to minus 1 and n is what? Minus 1 by 2. So we got the value of n. Here they clearly mentioned, sorry, geometric mean between two values. means they cannot, the values are not same. That is why we can take the value as power as what 0. Hope all of you understood this. So here they give geometric mean is this. What is geometric mean? A power n plus 1 plus b power n plus 1 by a power n plus b power n is given. This is geometric mean they have given. But you know geometric mean of two numbers is what? Root ab. Means these two are equal. So equate them. So geometric a power n plus 1 plus b power n plus 1 by a power n plus b power n is root ab. Now what you should do? Square on both sides. So right side square root vanishes and here a plus b the whole square. A square plus b square plus 2ab. Denominator also a plus b the whole square. A square plus b square plus 2ab. But law of indices. So in this problem many places we are using law of indices. So a power m whole power n. What is a power m whole power n? A power m into n. So here we have a power n plus 1 whole square. I will write n plus 1 into 2. When I multiply n plus 1 into 2, it will become 2n plus 2. That is how we got 2n plus 2. Here b power n plus 1 whole square is what? Multiply n plus 1 into 2, it will become 2n plus 2. And this denominator also a plus b the whole square is a square plus b square plus 2ab. A square means a power n the whole square. B square is b power n the whole square and 2ab. And n into 2 2n, n into 2 2n like this. Now simplify this. Then rearrange. After you rearrange and solve, you will get the value. And finally here very interesting. Here we can see a power n plus 2 and a power n plus 1. See, dear students, a power n plus 2 can be written as a power n plus 1 into a. So here if I write this as a power n plus 1 into a, I can take a power n plus 1, a power n plus 1 common. That's what I have done. When you take 2n plus 1 common, 2n plus 2 can be written as 2n. So a power 2n plus 1, if I take common, this will become a, because a power 2n plus 2 can be written as a power 2n plus 1 into a. So this a will be retained here and this is gone, so it is b. Same thing will do b power n plus 1, if I take common, this will be a and this will become b, because this can be written as b power 2n plus 1 into b. Law of indices, if you combine you will get this. This I'll write like this. So b power 1 is here and this part we took it out. And then we'll cancel the like terms and we'll get the required value. Practice this problem, one of the good problems. Thanks for attending the session. I'll see you in my next session. Please practice the problems what I have done. Thank you.